Hi everyone, I'm your host Faraz. So in this video we'll be solving the questions from the assignment that we uploaded for the topic dynamic programming. So the first problem is house robber. Let us try to understand the problem statement first. You are a professional robber planning to rob houses along a street. Now they want us to play the role of a robber, okay? Each house has a certain amount of money stashed. The only constraints stopping you from robbing each of them. Obviously, like if I'm the robber, I would want to rob all of those houses so that I can have the maximum amount with me. But the constraint that is stopping us from robbing that is if we try to rob two adjacent houses, it is going to contact to the police and we will be caught, wasted. Okay, so we cannot rob two houses which are adjacent to one another. Now we are given the values, the amount that is present inside those houses. Basically this is the amount in the house number 1, this is the amount in the house number 2, and so on. And now we have to rob them in a clever way, in a way such that we can collect the maximum amount at the end. Also, we are not allowed to select or to rob two houses which are adjacent. I hope the problem statement is very clear. It was a really simple problem statement. Looking at the constraints are really low. So now how to actually solve this? The first intuition that most of the people get if they landed to this problem the very first time without knowing anything about dynamic programming, without knowing anything about recursion or brute force way to solve this. So what they usually think is, let me just copy this example for that. 27931. Okay, 27931. These are the 5 houses. Now this is us, the robber. Okay, like this. What is this? This is the cap. Okay, this is the robber. Now I want to collect amount into this box from all these houses. Now the only condition is I should not rob two adjacent houses. Now what most of the people they do is they will see that which one is better among these two. They will see that if I should select this house or if I should select this house, and they will find that okay, let us go by selecting this house, 7. Okay, they will select 7 because they are greedy. They are going to select 7. Now because they selected 7, they lose the opportunity, they lose the chance to select the house which could give them 9, because now as they selected 7 they cannot rob the next house, the one which is adjacent. Otherwise the police is going to know. So this strategy doesn't work. You are not supposed to see the two adjacent houses each time. That strategy is not going to work in this case. Okay, so what is going to work here? So for that we should try to brute force this. So to brute force, what I mean is I should come to the first house. Now at this house I have two options. I have to make decision. The first option is either to rob this. After robbing this I will collect 2. Okay, I will be having 2 in my bag, but I will lose the chance to rob the house with the value 7. Okay, this is the first option, either to select 2 and lose the chance to rob this house, this particular house, and directly go to this one and then start robbing from here. This is the first option. What is the second option? The second option is to skip this house. We are at the first house. The second option is to skip this house. If we skip this, we can directly move to the next one. Okay, so out of these two options, which one is better? We have to identify that, and we are going to take that option. Now that is something that recursion is going to handle for us. Recursion is going to bring us the answer for both of these possibilities. The first possibility is to select 2 and to pick up 2 in our bag and go to 9. Okay, this is the first possibility. The second possibility is to skip 2. Okay, to skip this house and directly go to the house with the value 7 and start searching from here. So let me explain you with the help of the code. What I mean to say here is I'm creating a function help. This function help is going to return me the maximum profit that I can make, or the maximum amount that I can collect robbing all these houses. So I'll be starting with the house 0. So I is going to denote the house on which I'm currently on which I'm currently standing. So initially I will pass 0 into this I. The second thing that we need to pass is of course this vector of int nums. Again, remember this, you should pass this using a reference. Why reference? Because we are not going to change anything inside this nums. We just want this nums as it is. We are not going to make any changes. That is why always pass it as a reference. Otherwise, if you pass this without a reference, it will create a copy, and each time in a recursive call it will keep making copies and copies and copies, which will consume your space, your time, and it is going to give you TLE. So remember this thing. Then okay, we are at the ith house. Now for the ith house, if I is greater than or equal to nums dot size. What does it mean? What does it mean that I is greater than or equal to nums dot size? That means we are already at the end. We reached till the end. Okay, we are not left with any house to rob. We are here outside. If we are greater than or equal to nums dot size. Okay, here nums dot size was 5. Now greater than 5 means we are out of the range. So in this case, the profit that I can make is obviously 0. I will not be able to make any profit now. Return 0. Done. Now this was the base case. Base case is done. Now we have two options. What was the first option? Just let me write it. First option, option number 1 was to pick the amount present at the current house. That is nums of I. Pick nums of I. Okay. This is going to be added into your profit, plus whatever profit you can have from the house number I plus 2 till nums. Why did I pass I plus 2 here? The reason is, as I robbed the current house, that is the ith house, I cannot go to the I plus 1th house. I should skip that and I should go to the I plus 2th house in order to avoid the police. Okay, so if I select this, I should not go to this one. I should not go to I plus 1. I should go to I plus 2, this one, and then start my search from here. This thing, help of I plus 2 till the end, is going to give me the maximum profit or the maximum amount that I can collect if I am at the I plus 2th place. So this is what I need. Recursion is going to give me this one, plus the amount that I got from this particular house. This is my option 1. What is going to be my option 2? Option 2 is when I skipped the current house. So in that case, I need the answer from I plus 1. Okay, I want the maximum profit that I can make if I'm standing at I plus 1. Now I can go to I plus 1, right? These are my two options. Out of this, I'll be returning the maximum. So return maximum option 1, option 2. Let me just see if it is working. Return help of 0, nums. Now why am I naming this function as help? I should use some good variable names. You should be doing that in your interviews, but I am used to write this help for every recursive function that I make. I'm used to write this help, so you can do that. Now I'll be submitting this, and I will expect a time limit exceeded, maybe, if there are no errors. Yes, there are no errors. That is why we got the time limit exceeded. Why did we get time limit exceeded? Now for that, I will just draw the recursive tree for you, the recursion tree. So basically, let us say we have 5 houses. Okay, 0, 1, 2, 3. I'm writing them as the 0 based indexing. 0, 1, 2, 3, 4. These are the 5 houses that I have. Initially, what is my I? Initially my I is going to be 0. Okay, I will start from the 0th place. Now to find the best answer for this particular place, I need to search that whether I should take the option 1 or I should take the option 2. What's the option 1? The option 1 is to take this amount, to take the amount that is present at this place and then go to I plus 2. That means 0 plus 2 is 2. So to go to the second index. Okay. The option 2 is to skip the particular house. If I skip this one, I can directly go to the I plus 1th. So that is 1, index 1. Okay. Now to calculate the answer for this index 0, I need the answer for the index 2 and the index 1. Okay. Now again, if I am at the index 2, I will have two options, option 1 and option 2. Option 1 is going to be when I will be selecting whatever is there at this place. So if I select that, I should go not to this place but to the fourth place. So get the answer for fourth. Otherwise, if I skip this, that's the option 2, then I can go to 3. So to calculate the answer for 3, I need the answer for the fourth index and for the third index. Okay. Similarly, if I split this one to calculate the answer for this place, the first option is to take this amount, whatever is present at this place, to take that and go to the index I plus 2, that is 3 in this case. Okay. The other option is to skip this and go to the next index, that is 2. Now we can see here we already calculated the answer for 2. Again we are getting 2. So again, if we didn't store this answer somewhere, we will have to calculate it again by splitting this. Okay, it will cause a lot of repetition. Why do we need to calculate it again when we already had the answer for this? We already had the answer for 2 here. We already calculated it. When we are calculating, we should store it using dynamic programming. This is the repetition. Over here also this is the repetition. So whenever I'm calculating something, whenever I'm calculating the answer for a particular index, I should store it into a dynamic programming, into a vector or into an array. Okay, I should store it, and when the next time I'm at the same index, I can simply return it without just branching them out and going deep into the recursion. Okay. Alright, so here let me just try making some changes over here. Now you can just simply make a DP array here and then do it, but I want you guys to follow some good programming practices. So instead of doing that, instead of making a global DP array, just make it into the main function that you have and name it as DP. Then what should be the size of this DP? The size should be the maximum value of I that can be achieved. So the maximum value of I that can be achieved is 100 in this case. So we can make it a size 100, but I'm taking n. N is nums.size. I will not exceed nums.size, right? So I'm just making the DP of size this and initializing this with -1. Why -1? We already know this from the previous lectures if you haven't watched, but this -1 will denote that this particular state of DP has not been calculated yet. Okay. If it has already been calculated, there will be some other value, not -1. Initialize it with this and I will pass it over here. Vector of int dp if dp of I. Now here comes the role of -1. If it is not equal to -1, that means we have already calculated it. So return dp of I. Initially I'm putting it a -1 at all the places. So if it is not calculated, this if condition is not going to work. If it is calculated, it will simply return from here. But if it is not going to work, we will have to compute all of these things, and while returning I will store it. dp of I is now equal to this. Okay, so I should also pass it over here. The vector which I made is dp, and here as well dp, and here as well dp. Let us try to submit this. Why, I don't know why I'm so confident to just directly submit it without figuring out the errors, and I got the errors. Oh my god. Vector of int. Again I'm daring to submit this without running it. It got accepted. Okay, so now this was the top down dynamic programming. Now you need to convert it into bottom up. Okay, this is very simple. You just have to think recursively and then memoize it. Okay, this is simple. Now you have to convert it into bottom up. Okay, you have to convert the same code into the bottom up dynamic programming, and I should not forget to do this indentation. Okay, yeah. Alright, so let me just tell you how to do that step by step. We need this DP array. Now the first step is to look at this base condition. What is the base condition? The base condition is when I is greater than or equal to nums.size. For that, make everything 0. Okay, so first of all, let me just take the size over here as n plus 2. You will soon know why we are taking it as n plus 2. Okay, so obviously, yeah, dp of n. Okay, when I is equal to size, this should be equal to 0. dp of n plus 1 should also be equal to 0. Okay, this base case is handled over here. Alright, so just before going there, I want to show you guys something. Okay, so let me just store this answer somewhere, store this answer into this variable, and then I will print the entire content of this DP array, and after this I will return the answer. Let me just do this. Okay, I'm running this for this case, the given test case, and see here, forget about these places, forget about them. So look at this, the first one from the right hand side, this one. It gives me the maximum benefit that I can get, the maximum amount that I can get if I am at this particular index, the last one. And this denotes the maximum that I can get if I am at this position. This 3 denotes the maximum that I can get if I am at this position, and this 4 denotes the maximum that I can get if I am at the the 0th position. Okay, that's what it denotes. That's the content of this DP, and I'm doing nothing but I'm returning the DP of 0. Okay, so now just forget about this. I want to calculate a DP of 0 somehow, and for that I need DP of n plus 1. Now I will start going backward. Now look at this, look at these lines. To calculate the answer for DP of I, if DP of I is not already present, and if I want to calculate DP of I need the answer for I plus 2, I need the answer for I plus 1. So int I is equal to n minus 1, I greater than equal to 0, I minus minus, DP of I is equal to maximum of these two options. The first option is, let me just make the options over here so as not to confuse you. Option 1, this is nothing but nums of I plus DP of I plus 2. Now this recursive call, this particular recursive call, we just have to replace it by DP of I plus 2. Okay. Option 2 is nums, no, option 2 is just help of I plus 1, that means DP of I plus 1, nothing. Okay, as simple as that. Just replace this help by DP. Okay, now do you know that why are we taking the size as n plus 2? Because to calculate n minus 1 I need n and n plus 1. So okay, I hope it is clear. Now it will be the maximum of option 1 comma option 2. Finally we are returning the DP of 0. We calculate the DP of 0 and we are returning it. And let me submit this. Also remove this code, we don't need it anymore. And it is submitted. Clear? Alright. Now what is the benefit of converting it from the bottom up to the top down? Although the complexity is same, but the runtime of this, the bottom up, is much better than the top down, because there's the extra cost of those recursion. Okay, recursion takes a lot of processing time. Okay, but here we are not going anywhere else, we are just inside this particular function, so that is why this is much better. But the benefit comes when we will try to optimize the space complexity. Now we can see here, to calculate the answer for DP of I, to calculate DP of I, what do I need? I need DP of I plus 1 and I need DP of I plus 2. Okay, rest of the DPs, that is I plus 3 till the n minus 1, I don't need them. Okay, I just don't need them. So why to create an entire DP array when you only need 2 values? So initially we need these 2 values. Let me just make them as int a equal to 0, int b equal to 0. Okay, I don't need this as well. DP of I, am taking it as the third variable, int c, maybe, yeah, int c is equal to maximum of these two options. Now instead of DP of I plus 2 I should write b, instead of DP of I plus 1 I should write a. Alright, so I just replaced I plus 2, DP of I plus 1, DP of I plus 2. I want to calculate DP of I just replaced it by b, I just replaced it by a, and I made it c. So I will be able to calculate this C using these two values. But when I want to calculate the value which is here, this is dp of I. When I want to calculate dp of I minus 1, I will need this and this. So I will have to make this B and make this as A. So I will show how to do that. Now B, which was earlier B, it should be equal to A. It should be equal to A. And which was earlier A, now it should be equal to C. Okay. Finally, at the end, I will have to return A, because that denotes whatever is there at dp0. It got accepted. What is the benefit? Earlier we were creating an entire vector to store all the states of dp, and all the states of dp were not required at a time. Okay. We know that we only need to return dp of 0. So our purpose is to calculate dp of 0. But to calculate dp of 0, we don't need to store the entire dp array all the time. Answer for the entire states. That's why we are just creating these two states, and we are just doing the work using these two variables only. The space complexity is very much optimal here. The space complexity is big O of 1, constant space. There earlier it was big O of n. Okay. The time complexity is going to remain same. Anyhow, we are going from I is equal to 0 to n minus 1, or vice versa. But the time complexity is big O of n in this case. Okay. I hope this solution is very clear to you. I hope you have learned a lot of things from this, and you will be able to do this question if it comes into your interview, or if a similar questions come into your interview. This is how you should be doing, top down, bottom up, and then try to optimize that bottom up. When the interviewer is going to ask you what is the optimization that you can do here, can you do something better in terms of space, you will say yes, we can do something better. We only need these two variables. We don't have to store the entire dp array, and then proceed like this. So I hope this problem, house robber, was very clear to you. I took some time explaining this so that you don't face difficulty in the future lectures. Okay. And few of you who don't know what this question is a part of, this is a part of a series which I am making for your interview preparation. So there are lots and lots of questions. You should go and check that playlist out. The link will be in the description. You can go and check it out. If you want to ask your doubts to me, like if you have any doubts, if you want to attend the live doubt sessions, for that you should join the Telegram channel. The link of the Telegram channel is in the description. Check it out and make sure you join it so that you can participate in the live doubt sessions. Okay. Thanks a lot, guys. This video is already too long, and I'm making it longer by just speaking and speaking. So take care.